Hello, yes, it is working. Right, good morning everyone, and welcome to the technology pitch, energy efficiency technology pitch. My name is Martin Fry. I'm the moderator for this session. I'm the president of ESTA, the Energy Services and Technology Association, and I also chair the BSI Energy Management Standards Committee. And I've got other roles at City University, where I'm a visiting professor, City University in London, but enough about me. We have 4 pitches this morning. The first pitch, why LED lighting has become the technology of choice for many commercial lighting applications and its future opportunities, is Christopher Dawes, Director of NET LED Lighting. Our second pitch is decentralized energy generation, wind turbines, an efficient way to keep business competitive. Julian Martin, co-founder and CEO of ICE Renewables and chair of Renewables Small and Medium Wind Strategy Group. Our third pitch is solar PV, obtaining the best system for your land and roof space, a subject close to my heart as I've had a PV panel for 10 years or so on the roof of the house. This is Mike Carter, Managing Director of Ikaros Solar. And then our final pitch, which is a fascinating title, Camping in England, so why buy a tent that's suitable for the Arctic? Well, you can start to think about what the implication of that is, and that's Erika Wilson, Managing Director of Wilson Power Solutions. So we've got a very interesting session. Our pitches, I'm instructed, are 5 minutes each, and we must keep to that, and then we have some time at the end for general interaction and discussion. So without more ado, let me introduce Christopher Dawes, Director NET LED Lighting, on why lighting has become why LED lighting has become the technology of choice for many commercial applications, but in fact I've got it at home, and I'm sure many of you will have as well. So, Christopher, over to you.
Good morning. Can you hear me? Yes. Thank you for inviting me to talk today. My name is Christopher Dawes. I'm Sales Director at NET LED Lighting. We're based in Cambridge. The company was founded in 2009, and we distribute quality white light commercial LED lighting throughout the UK and Ireland, mainly through the major electrical wholesalers. We're also a member of the Lighting Industry Association. In the limited time available today, I will be presenting on commercial LED lighting applications, not domestic. So why has LED lighting become the technology of choice for many commercial lighting applications? First of all, it's to do with efficiency. A lot of conventional lighting is based on mains voltage gas tube technology, whereas LED lighting is much more efficient, low voltage, solid state electronic technology. Over recent years, the reliability of quality LED lighting has improved significantly and is now greater than 50,000 hours. Production volumes have increased massively, and good suppliers from reputable manufacturers include people like Cree, Bridgelux and Epistar. And prices are being driven down due to economies of scale with the increased production volumes. This has resulted in LED now being accepted by various markets, and we're seeing them being used in a number of applications, including car lights, traffic lights, mobile phones, television screen backlighting, as well as in buildings. This growth is expected to continue year on year, and recent studies have shown that in Europe, in 2011, there were about €1 billion sales of LED lighting, with the expectation growing to about 9 billion by 2020. So, I'm now going to move on to some of the benefits of LED lighting and why it's become the technology of choice. Primarily energy saving, which means electricity cost savings, of course, and these can be typically around 60%, with the associated lower carbon dioxide emissions, making the technology very environmentally friendly. LEDs have a much longer life expectancy than conventional lighting, typically, as I said, 50,000 hours, and in many cases, and the luminaires are maintenance-free, can be maintenance-free, resulting in maintenance cost savings as well. This longer life also means fewer lamps to recycle, again, making further savings on recycling and generating less waste. And the increased efficiency of LEDs means less heat output, heat that's not being put back into buildings, which can enable a reduction in the air conditioning with the additional energy savings here too. And this is particularly important, of course, for refrigeration cabinets and cold rooms. LED lighting doesn't contain any of the toxic chemicals found in fluorescent lighting, such as phosphor, mercury, and lead, making them more environmentally friendly and providing recycling benefits. And unlike gas tube lighting, there's no glass in most LED lighting applications, making the lamps less fragile and, again, easier to recycle. A lot of fluorescent lamps emit UV light, which damages health, works of art, fabrics, and other materials, such as insulation on wires, but LED lighting does not emit UV light. LED lamps can be cycled off and on quickly. They come on at immediate full brightness, so no warm-up time is needed. And another financial benefit is that quality LED lighting qualifies for the government's Enhanced Capital Allowance scheme. Moving quickly on to some of the future opportunities for LED lighting. LEDs are low-voltage DC devices. We currently have to take mains voltage AC to low-voltage DC through a transformer or driver. In the future, premises are likely to be powered by a low-voltage DC network within the building, which may be generated by solar or wind. This will further reduce costs, removing the need for inbuilt power supplies and transformers, and increasing the efficiency. As I mentioned, LEDs are electronic devices, so can much more easily be controlled electronically, and we're going to see an emphasis on electronic controls such as presence detectors and daylight controls. And Wi-Fi has already been incorporated in some LED lighting systems, allowing the control of any lamp or group of lamps simply from a mobile phone. We have heard a lot about the Internet of Things recently, and lighting is one of those things. We are increasingly going to become accustomed to lights that communicate with each other. So, for example, they will sense you approaching in a corridor, and the lights will gradually brighten ahead of you and dim as you pass. Now for the brief commercial plug. If you'd like to come and see some commercial white light LED lighting, please visit us on stand M10. Thank you very much.
Thank you very much, Christopher. Right, our second pitch is decentralized energy generation, wind turbines, an efficient way to keep business competitive. Julian Martin. Julian, over to you.
Thank you very much. I'm Julian Martin. I'm the Chief Executive of Renewables. We sell, install and operate wind turbines in a distributed setting. That means at the end of the grid, rather than conventional power stations where you might generate energy and send it from a central location, we're right at the end, putting power into the grid where it's needed. Now, why wind? Well, we hear a lot about North Sea oil, we hear a lot about fracking. Well, we have a huge resource in wind in the UK. We probably have the best resource across the whole of Europe, if not the world. It's free, it's renewable, it's sustainable. And about 32% of new installations across Europe at the moment, that includes things like gas-powered power stations, are indeed wind turbines. And I believe wind at the moment is the largest proportion of new power that's going in across Europe. Some recent figures in terms of wind generation in the UK. It's expected that 14% of generating capacity will be on site in one form or another by 2030, and that will be quite a large increase, 130% increase over where it sits today. And wind is expected to be the major contributor of that increase. And we're talking about wind turbines here which are put into agricultural settings, perhaps farms, and certainly in the future into commercial settings, next to factories and other buildings that have a high power demand where the power can be fed straight in to those sites. And the estimate in this report that was done by Utilix just at the end of last year is that there'll be £33 billion worth of saving potential by 2030 from distributed energy. Now, you've probably heard of the feed-in tariff, which supports wind turbines. You get a payment for every unit of power that you actually produce. You get a payment for any unit of power that you spill back to the grid. And probably the main thing from a business point of view is you get an energy saving on your bill for every unit that you consume. And I think increasingly this is going to be important because that's going to be a higher component of the support mechanism for wind. And ultimately, as the support mechanism dies out, because we're seeing it digress and reduce, it'll take over as being one of the primary reasons why businesses will install wind. In terms of a typical payback period, anywhere between 4 and 10 years, depending on the turbine size. Generally, the larger a turbine you can go for, the faster the return on that investment. And the way that the capacity bands in the feed-in tariff work, there are some sweet spots, 100 kilowatts, 500 kilowatts, 1.5 megawatts. But generally, going larger is better. But there is a cautionary note, which is it will depend on what the annual electricity production is going to be from that particular turbine, and you should always check what the manufacturers are stating about their machines. But as energy prices continue to rise, the payback actually improves and it comes towards you. So again, as I was saying earlier, you put that together with a reduction in energy bills and you start to see a sustainable market that doesn't need the support that it has today from government incentives. Turbines have a 20-year life and the feed-in tariff runs for 20 years once you've installed and is index linked as well. So you can have certainty or as near as good certainty of your return on investment right from the start. And what you really need is a company that is operating this turbine well, making sure that it continues to produce over the 20 years. Business benefits, on-site, security of supply. So in the future with more intelligent switching and connection, you can make sure that the lights don't go out on a business premises. Effectively, we're starting to look at microgrids where we're trying to put turbines linked to storage facilities. At the moment, probably lithium batteries are what most people are looking at, but in the future, in the next few years, probably hydrogen storage where we can convert energy into hydrogen and then back again into electricity as it's needed. You could then use that hydrogen to power forklift trucks, vehicles as well. So there are lots of uses for stored energy. Energy costs will be more predictable. You've got a guaranteed supply. You can see where the power is coming from. It's being generated in the corner of your site. And you can then predict for the future, keeping the costs down. Zero emissions, obviously from the point of view of making sure that we move to a zero carbon economy as a business, you can potentially move to 100% renewable by using wind turbines and other forms of on-site generation to do that. It's a positive message. So as a business, you'll quite often see that a lot of public relation work is done around wind turbines once they've been installed. It's a very, very positive and visual message for your business. And something that maybe you don't know, but if you put a turbine on the end of a grid, certainly where grids are unstable in maybe less developed areas, you actually stabilize the grid, which has a positive impact on that grid. So thank you very much for listening to my pitch, and I'll pass on to the next person. Thank you.
Okay, thank you very much, Julian. Our third pitch then, staying with small-scale renewables, solar PV, obtaining the best system for your land or roof space. Mike Carter. Mike, over to you.
Good morning, everybody. So yes, a little bit about Ikaros first of all. We're an EPC contractor, small scale. We do some reasonable commercial scale, 50 kilowatts. Largest system we've installed is 17 megawatts on a single system. We specialize in commercial and utility scale projects. If you are interested, just a quick pitch, like everyone else, we're at G30, which is 2 stands that way. What are the key advantages of PV? First of all, it's really scalable, regardless of your project size. Martin, did you say you had 1 solar panel on your roof? 1 kilowatt. Okay, so I've said 4 kilowatts, but you can have 1 kilowatt. And the biggest systems are up to 100 megawatts. but typically in the UK on a big building, be between 250 and 1 megawatt, 250 kilowatts, 1 megawatt. It's extremely reliable if it's installed properly. Very predictable output by renewable energy standards. The solar resource, believe it or not, in the UK is fairly consistent, although it does vary month by month. And it utilises a resource that all businesses have, roof or land. There's also a key other benefit on PV is that there are no planning requirements for most rooftop projects. That's a big change from the original rules. But on commercial scale now, if you've got a standard installation, you don't need planning permission. A couple of predictions on what's going to happen on PV on the commercial side. I think that there will be many more larger scale rooftop projects coming. You can see that people are beginning to adopt those. Some of the big car plants have got very large scale projects on. I see a lot of multi-site funded solutions coming. We also see quite a lot of off-balance sheet projects coming where investors are actually funding the system and putting in place a power purchase agreement with the business owners. And then finally, with the grid being fuller and fuller, I see a lot of self-consumption. So that's where the business is consuming every bit of power which is being produced by the rooftop system. I was asked to do something from a customer's perspective, so I'm afraid I've cheated and just nicked the presentation from one of our customers that he did at one of our breakfast meetings about PV. So this is a project called Morgan down in Swansea. It's a 250 kilowatt project. It's 772 or 722 panels. Generates about 66 homes. Took us about 6 weeks to build. The actual build process was quicker, but there's a little bit of design time as well. The carbon savings, which is probably the most interesting thing here, 200 tons of CO2 in the last year. And what to look for when you're looking for a solar PV system? What are the key items? Well, first of all, is it the right size? We spoke about sweet spots. This particular one at 250 kilowatts is a real sweet spot. Anything between 50 and 250 is good, and then really it goes to bigger is better. Have you got good panels? Have you got good inverters? The most critical item for me is that the monitoring system works. It amazes me how many people buy a 50 or 100k system and then don't pay for decent monitoring. Absolute madness. Now you can see down here on the bottom right, monitoring system, this particular project doing exactly what it said on the tin. Then your installer really needs to know about shading, maintenance. Look at the timings for feed-in tariffs, they digress regularly. And finally, you can get really good warranties on PV systems. Anything above 100 kilowatts, 150 kilowatts, you can even get a yield guarantee. And what to look for in a supplier? Competence, references, experience. We come from the Low Countries, so Belgium, where there are huge numbers of large-scale rooftop projects. Can the supplier provide you with models of your roof, CAD drawings? Can they help you with interaction with the DNO, planning, even filling in the feed-in tariff forms sometimes is a bit of needs a little bit of help. Financial strength, clearly, no point in having a 20-year system with no one to stand behind it. And then payback, typically around 7 years at today's cost. Does vary dramatically depending on where you are in the country, but somewhere like Birmingham has actually got much better solar resource than people generally think. Oops, I've got a much more interesting one up there, sorry. So thank you very much, and as I say, we're at G30 if anyone would like to see or understand some more. Plus a video that didn't quite work on the system here. Thanks very much.
Thank you very much. Thank you very much, Mike. Well, now, pitch 4. Well, I pitch my tent every summer. I love it. Camping in England, so why buy a tent that's suitable for the Arctic? Well, Erika Wilson, please tell us. Welcome.
Thank you very much. I'm frightened now because you've made me sound like I'm so interesting. But here we go. So, thank you very much indeed, everybody, for taking the time to come today and listen. My name is Erika Wilson. I'm the Managing Director of Wilson Power Solutions, and we're a company based in Leeds. We're in our 67th year of trading now. And we supply distribution and power transformers to our customers and switchgear products. And we supply throughout the UK and overseas. So the question is, if you were camping in England, maybe in the Dales or somewhere, would you really buy a tent that's suitable for the Arctic? It's a strange analogy, but the fact is, if this product fits your application and it provides superior product performance at the right price, then why would you pay up to twice the price with other competitors for more functionality than you actually need? So statistic here, staggeringly, transformers are silent energy guzzlers, wasting an estimated 3% of all energy generated worldwide through transformer losses. So we as a business set out to create the UK's first super low loss transformer. And the concept was easy. There's two types of energy losses when a medium voltage distribution transformer is live. These are copper losses and core losses. Now, copper losses, sometimes referred to as load losses, depend upon the varying load of your transformer. And core losses are fixed. So they're present from the moment the transformer is energised. So effectively 7 days a week, 365 days of the year. There have been efforts to improve the energy efficiency of transformers over years in Western Europe and the US. So-called low-loss units would offer reduced load losses through conductors with a greater overall surface area. And in countries where supply infrastructure is notoriously unstable, such as India, efforts to reduce core losses permanently led to development of core materials with better energetic profiles, such as amorphous metals. Now, the Wilson E2 transformer is the first distribution transformer in the UK to combine these two energy efficiency approaches. So combining the amorphous metal cores with low current density conductors, the unit's core losses are reduced by up to 75%. And as a rough guide, overall cut transformer losses in half, making the E2 the most energy efficient distribution transformer in the UK. There are also additional savings that can be achieved through voltage optimization. You'll have heard of this before, and it's very much dependent upon your load profile at site and the supply voltage of individual sites. But in a nutshell, the transformer will be designed to deliver that required site voltage without the need of additional downstream voltage optimization equipment. So you can see here in the schematic, it illustrates the concept. So on the right hand side you can see how voltage is actually managed at source through the supply transformer, and then on the left hand side that shows dedicated voltage optimization equipment that is actually installed downstream of the transformer. So the reason why it's cost effective is pretty evident here. So you've got a two-in-one solution and it minimises your plant footprint. And you also avoid additional system losses through cabling and things like that. Now, we appreciate that site supply voltage can actually fluctuate, the incoming site supply voltage. So we also offer a product with an automatic on-load tap changer, and it has an AVR relay there. So you can actually fix your output voltage where necessary. So let's just ask that question again. Do you really need to pay up to twice the price for more functionality than you really need? The best way to show this is proof in a case study. So here, Tesco had embarked on a rollout program, and what they were doing was installing dedicated downstream voltage optimization kit. They originally specified the Wilson E2 on the basis of those reduced transformer losses, and just the transformer losses alone. But then when we informed them of the additional benefits of the voltage optimization, they've now altered their policy. So now they install the Wilson E2 for stores supplied at medium voltage, and a secondary piece of kit for stores where there's only an LV supply. So after over 90 installations with Tesco, an annual savings of in excess of 9 million kilowatt hours per year, Tesco actually recommends the Wilson E2 as part of an integrated energy efficiency approach. So just to highlight the extra capex of this product compared to a standard loss transformer, it would be paid back in 18 months. And that's just through the transformer losses alone. So over a 25-year estimated life, you'll save over £70,000 in running costs just through those losses alone in the transformer. Great. Today we have over 400 successful client installations, and we supply across a wide range of sectors. Thank you very much indeed for taking the time to listen to me today. We are on H25 if you want to come and chat later. Thank you.
Right, okay, well, thank you very much to our 4 speakers. We now have some time for questions and discussion. So do we have any questions, please? Well, can I just one question for on the wind turbine for Julian. Sorry, you might have said something about this, but when you're putting a wind turbine on a building low level, you've got to check the wind regime, I think, have you, to make sure that you're not shielded by trees or other buildings and so on.
Yeah, that's absolutely true. We always recommend that you do a wind assessment, and what we're looking at is the wind speed at the hub height, which is critical, and we're also looking at turbulence and looking at wind shear, which is the difference in the force between the top of the blade at the top of its rotation and the blade at the bottom of its rotation. And different turbines have different wind class, or they're designed to different wind classes, different design standards. So you should always check that the machine that you're putting in is the right machine for the regime it's going into. And usually it's the turbulence and the shear where you lose power, and you do need to allow for that. And in some cases, we have had one case recently where we recommended that you don't install a wind turbine because those forces were too high. Yeah.
So you as an installer would carry out some of those trials, would you, and just check the regime and...
Yeah, we actually, my company won't install a turbine without having done that wind assessment. We just have a company policy that we just don't do that. Yeah.
Right, do we have any other questions, please? I can't believe we've... Yes, one over there, gentleman over there. Would you like to say who you are, please?
Michael Bubb, farmer from Shropshire. I understood with the transformer that it was the property of the power line people, and we pay the meter after the transformer. Perhaps I've missed a point somewhere.
Yeah, that is right. If you're metered at LV, at low voltage, then you won't own your own transformer. So this is specifically for people that have a medium voltage supply, which is typically 11 kV. So if you're a larger consumer, you would have your own transformer that's owned by you. It's your asset, so you can change it if you wish. Yeah. In your case, unfortunately, you don't own your own transformer, so it probably wouldn't be applicable for you. Sorry, I couldn't hear you there.
But I'm not paying for the inefficiencies either. Is that correct?
The transfer, you will be, yeah. If you're metered at LV, no, you shouldn't be paying for your transformer losses. But yeah, if you're metered at HV, then you are, yeah.
Okay, we're not that big yet. Thank you.
Okay, thank you. Do we have any other questions, please? Yes, gentleman here.
I'm Niles from Appetito, UK. I'm just wondering, if we're going to build a wind turbine on site, how do you deal with the noise problem? The noise.
Okay, noise is something that we always have to assess during the planning application. the manufacturers produce their own measured noise information that should be done to the international standard, to the IEC standard, which you should be able to get from any reputable manufacturer. And then usually you take that data to an acoustic consultant who will model the drop-off of that noise in decibels from the source to the nearest resident. And increasingly, actually, we're now seeing we're having to do that for cumulative turbines, where we've got 2 or 3 turbines and model the 2 or 3 together. But you would do that, put a noise model together. You may need to do some background noise testing as well at the residential receptors. So there's quite a lot of work you need to do, and you need to prove to the planning authority that you've met the nighttime decibel levels before you will be able to get planning approval.
Thank you. Yeah, gentleman there.
I'm Jay from Vital Energy. I had another question on wind turbines. You said they lasted about 20 years. What happens after 20 years? Do you have to decommission it, or is it a case of you can just sort of leave it there? What happens?
Okay, what I meant was the design life is 20 years, so the manufacturers have to make sure they last at least 20 years. What should happen really is if you maintain the turbine properly and perhaps refurbish it after 20 years, it will keep running. So even though the feed-in tariff will have stopped at that point, you can still benefit from the energy and it can still power your plant or your factory or whatever, so it will keep running.
Thank you.
Frank Ingalls, Forestry Commission. I'm trying to get the Forestry Commission off the grid by 2023. What should I use, wind or solar?
Depends how close to the trees you want to put the PV plant. So,
Well, I guess the trees would
we're
affect
we're not short of land.
yeah. So, well, it's a little bit unfair. I used to work in the wind industry, so I did quite a lot of the work with the Forestry Commission in Wales for large-scale installations, and the issues there with high turbulence, trying to build turbines into existing gaps is really quite complicated. On solar, well, I guess I moved from wind to solar, so I'm going to be somewhat biased. But if you want to get it off the grid, I'd say that solar is a really good system. It is more reliable, no moving parts. You won't have the issues or the same difficulties with planning. You do need a lot of land. The only other item is that you can also do a mixture, so it doesn't need to be one or the other. When solar is producing, of course, it's only during the day, and it's very much more production in summer than winter. Wind is not quite the opposite, but much more winter than summer, and nighttime, daytime.
Yeah, I was going to say actually that hybrid systems, which we haven't really discussed, but that's clearly the future, I think. But from a wind turbine point of view, you've almost got the opposite, because if you can get away from the turbulence, it doesn't have very much land take, and turbines generally will produce more power than solar, where you can get them in. So it's more difficult to get them in, but once they're in, they will perform better. So the return on your investment should be better. As I said, perhaps as low as 4 years.
Okay, thank you. We haven't had any questions on LEDs yet. Does anyone... how many people here, as a matter of interest, use LEDs in your home or your business? Okay, about a quarter or so of those here. Presumably LEDs are the way forward, and are we going to see compact fluorescence disappearing eventually?
Yes, almost certainly. About 20% of the world's electricity is used for lighting, and it is widely estimated in countries all around the world that by 2020 the majority of that will have moved to LED lighting. We're going to see a lot of developments, I think, in this area, both in terms of the types of lighting that's being used, and also a lot of research that's not caught up with the technology of how humans interact with lighting. With now the versatility of lighting and lighting controls that LED is providing, people are realizing that people are affected by their lighting environments very much. I mean, we all know that. If you're going to have a romantic dinner, you light candles. If you go into a place of worship, it's got a different type of lighting than if you're at a rock concert where the lighting is there to excite you. So at those sort of core levels, we know that, but we don't know how it affects you during a working day. Different color temperatures of the light throughout the day affecting your biorhythms, if you like. And there's a lot of research starting now to see how this might, how humans might interact with their lighting and how lighting might interact with humans. And I think we're going to see a lot more of that developing, as well as the technology of the actual lamps over the next 10, 15 years.
Okay, thank you. Interesting point. Okay, any other questions? Yes, gentleman here, and then gentleman back there. We've got another 5 minutes.
Mike Keast, Omnivis Consulting. One of the resistances I've got from my wife when I put LED lights into our house was that she didn't quite like the quality of the light. And you can either have, the warm ones are quite good now, but you can either have warm or the standard LEDs. Is there any developments in the future which will give us more adjustment or something closer to actual daylight or to an incandescent bulb type of quality?
Yes, I mean, you can actually get any color temperature you want from LEDs now. Unfortunately, what's happened is a lot of people have imported standard commercial lamps, cheap lamps, which are very cooling in color temperature. They're fine for a commercial type environment, but they're not so comfortable in the home. There's also another factor called color rendering index, which is very important. This is to do with the fact that white light is made up of all the colors of the rainbow. And the reason something looks blue is because it's actually absorbing all the colors except the blue, which it's reflecting. Now, if the light that you're shining on it is deficient in blue, my tie would look gray. And so you get this effect as well with the cheaper LED lights. They have a poor color rendering index. They don't have a good mix of all the colors of the spectrum in the white light. So you get a duller, grayer type light from them. And if you have got a cold color temperature as well, it can make you look quite sick. So this is a common complaint, but it's actually a totally unnecessary complaint. You can buy color rendering index lamps with a CRI rating of over 80, which is a good mix of all the spectra, and also nice warm lights to make you look fresh and healthy. So it is just a function of the lamps that are being sold, unfortunately.
I think everyone's buying the cheaper lamps. That's what you just see them on the web and you think, right, they're cheaper, I'll go for those. Yeah, it will change. I mean, more and more people are selling warmer, higher quality lamps, and the prices are coming down. So, the more expensive ones will become cheaper, I'm sure. Okay, it's all in the marketing, I think. It needs to be marketed to show that quality.
I agree.
It needs to be explained to people.
I agree. It's something that in a commercial environment people take into account much more, but unfortunately in the domestic environment, people just pop into the local store and pick up whatever's on the shelf, and they're probably not aware of things like color rendering index and color temperature, which is what you're talking about. Okay. And also the angles of a lot of spotlights, they can be very tight, and so you get sharp, pointy lights, but you're not getting a good broad light. And again, in a home, this can be unpleasant if you want a more ambient light.
Okay, thank you very much.
Okay, thank you. I think there was one more. This will be the last question, gentleman there.
Hello, my name is Wally. I'm from Cranford University. About a year ago, I used to work in a firm that used to dabble into renewable energy and energy management systems. And one of the things we used to do was recommend LED lighting for our clients as part of the ways of saving their energy. One of the problems we always had convincing them was cost, availability, and replacement. People tend to be more comfortable with, like you said, something they can just walk into a store and just buy, and it's easy to just fix up there by themselves. And we always try to push it to them that, yes, the hours are more, 50,000 hours, like you said, but convincing them, especially of those three things, is always a problem. So what's been done about that?
There's a number of things there. Cost. First of all, costs are coming down, as I mentioned in my presentation. They're coming down a lot. They've probably halved over the last 6 years in round figures. And they will continue to come down as volumes increase. But there is another factor, as you mentioned, the long run life, and you get a situation, take a fluorescent tube, for example. You can buy a reasonably good quality fluorescent tube for £3 or £4. You can buy an LED equivalent for about 20. Now, that at first sight seems a lot more money. But when you take into account that the fluorescent tube also needs ballast and starter to run, and you're probably going to change the fluorescent tube 3 times during the lifetime of the LED tube, and you're probably going to change the ballast once, and you're probably going to change the starter 3 times. You start adding up the hardware, and it actually works out probably about half the cost just of the hardware than the LED lamp. And then if you take the labor into account to do that, and we're not even talking about the energy saving here, you'll find that actually the fluorescent, during its cost of ownership during its lifetime, is actually much more expensive, even excluding the running costs, than the LED lamps. So it's a function of perception. If you're just comparing the tube with the tube, yes, the LED is a lot more expensive, but you look at actually the cost of ownership of the products, and it's not. And then you take the energy into account as well, and it's a no-brainer. You'll find that the LED tube will pay for itself probably 4 or 5 times during its lifetime compared to a fluorescent. You mentioned some other points about reliability which relate to that.
Yeah, and then replacement.
Well, replacements, again, because you're probably talking 50,000 hours for a quality lamp life expectancy, replacement is a lot less. There are reputable suppliers such as ourselves who can provide replacements as and when they're needed. On the subject of replacement, another thing that's happening as well is that people aren't thinking of, if you like, a light bulb to replace in a fitting anymore. That because they are so reliable, manufacturers are actually making complete luminaires, which without changeable lamps. So you would actually simply replace the whole luminaire if and when it comes to its useful end of its life. But you might be talking 15 years of use, which is probably long enough, particularly in a commercial environment.
Okay, well, that's an interesting point. Thank you very much. So we've come to the end of our session. So thank you very much to our speakers this morning. And thank you all for coming and engaging. Thank you. Interesting point.